Thank you all for coming. I'm Elijah MacCarthy, and I'm with Oak Ridge National Lab. I'll be talking about integrating CI/CD into the NCCS Software Provisioning tool. This was work done at the OLCF by the System Acceptance and User Environment Group. Myself, Fernando, and John are part of the team. We have a couple others, Nick, Thomas, and Asa. So Fernando, Asa, and Nick are called to the NSP, and I came in to try to have a way we can automate this using some form of CI. Okay, so for most of us here, we already know about the NCCS. So NCCS has deployed several top supercomputers over the years, the past 2 decades. It doesn't only deploy systems for the OLCF, but also for the US Air Force, for the National Oceanic Administration, NOAA, as well. And all these systems that have been deployed at the times when they were deployed, they are either first on the top 500 or they are part of the couple that are up, very high up. We have a discovery coming up 2028, but for all these systems, getting to the very top of the top 500, pushing the boundaries of science. Different software, the scientists that run on these systems must have access to different scientific applications or scientific software that will help them get their science done. And so when there are a number of this software, when you have vendor-provided packages and compilers and optimized libraries that you have to integrate with packages from your site, and you have heterogeneous systems, those all add to the level of complexity of building software. And so it can get messy, especially when you have to switch between environments, between Spack environments. And in our case, for instance, at the OLCF, at one point we had a Spack.yaml getting so big, more than 1,800 lines of code. And so at some point we had to freeze between switching environment because there were several hacks that were put in just to make sure that it was working. And so only one person was handling it, and we felt it was sort of a bottleneck. And so we started exploring ways to get this streamlined a little more. And so Fernando came on board, and then NSP was conceived. So NSP is the NCCS Software Provisioning tool, and it's infrastructure. It's a configuration as code focus tool that deploys trackable software. It has Ansible that sort of writes on Spack LMOD, and has and so we use that in deploying software that we can track as well. So through LMOD hooks, we are able to track the software, how much of a utilization there is to the software, and we determine whether a software should be made available or should be dropped when there are updates and we are putting up new software. And so within Ansible, we have a Spack role. Okay, so I'll talk about the roles on the next slide over here. So we have several roles within the playbook. One of those is the Spack role, and Fernando had talked about this more extensively in HBSF last year. So, but this one is just more about the CI part of it. So the Spack role sort of downloads Spack, checks out specific versions, configures Spack. Then we have an LMOD role that also can install LMOD, configure it as well. We have roles that build or install different compilers as well, like GCC. We have NVHPC as well, and the Intel One API. So there are several roles, and those are targeting different systems because this is more of a templated approach, so it can switch between different systems. So when you see something like NVHPC, Frontier does not have NVHPC, but because it's templated, we take this template and we can implement it on a different NCCS system as well. So right now we have about 13 NCCS systems that we've implemented NSP on. So when we started this, in terms of CI, this was what we envisioned, having Jenkins that would sort of automate everything for us. And so we started with this, stood up a Jenkins server within one of our, on a pod within our Kubernetes cluster. And there were a couple restrictions. So we are able to actually authenticate or set up connection from Jenkins to our open enclave systems, because those use either passwords or SSH keys. Now, we have a different enclave, which we refer to as the moderate enclave. That does not use, it does not allow for SSH keys or password, more of a static pane and a dynamic RSA token. And so it became a bit challenging how to set up a connection from Jenkins to those moderate enclave systems. And so we got stuck a little bit trying to go through security and see ways we can circumvent that, whether we can have a Jenkins user that would go through, get established connection with the moderate enclave systems without needing the RSA authentication approach. And so it took us a little bit, and then while we were brainstorming and finding ways around this, we realized that on some of our moderate systems, we have Jacama CI, which is more like a custom a GitLab runner that sits between HPC systems and GitLab runners. And so that was already available on Frontier, and so we started exploring ways by which we can utilize that. So our NSP configurations and everything sit in an internal GitLab repository, and so we were able to set up GitLab CI attached to the repository that has all the Ansible config files and all that, and so that could actually help us to establish connection with the moderate enclave systems using Jacama CI, and then can have Ansible run the playbooks, and then Spack will take over from once the Ansible playbooks are done running. So that's how we were able to actually get around this on our moderate enclave systems. But it took us a little bit to get there. So for the setup right now, the way we have things set up, so any member of the team or anyone within the software team can actually go ahead and work on their whatever software they want to install with Spack, or whichever way they want to do it, they can work by themselves. Now, when they do that, they have a local staging area where you concretize and install and make sure everything is working, all dependencies are resolved and there are no issues. Now, once you are certain that the packages concretize, everything installs smoothly without any issue, then you go up and upstream that and create a pull, a merge request against our pipeline branch. So that would automatically trigger the pipeline for us that would go ahead and run the playbooks and do the installs. So that's how we have it set up right now. So when the pipeline is triggered, what happens? So we have Ansible that through templated recipes is able to, that we can use to run the playbook. Now, when Ansible is running, as part of the plays that we have the Spack role that would have several tags. One of those tags would be to download Spack and check out specific versions of it, configure it. Another one would be the lmod role that would also install lmod and configure it as well. So we run the Ansible playbooks. When we run the Ansible playbooks, we detect all environments or all Spack environments that exist within the Spack role, within the playbook of whichever system it is. When we detect all those, we also try to detect if there has been any updates to environments that have already been deployed. Okay, if there has been any updates or there has been any new environments that have been added. And when there are updates or new environments that have been added, then we go ahead, after the Ansible playbook is run at the build stage, we go ahead and have Spack install those packages. When there are no new environments or no updates, then our pipeline will just terminate gracefully at that point. Okay, so with the pipeline schedule, so I talked about it being triggered when there are pushes to say when there are merge requests that are created. So two rules that would trigger the pipeline: either there's a pull request made against the pipeline branch or the main branch in this case, or there's a push against the main branch. So those will trigger the pipeline, and when it triggers it gets to the build stage, and it does 4 things. It's gonna run the playbook. It's also gonna dictate, or we have an algorithm that would go in, look at the playbook, look at the Spack role within the playbook, and be able to capture all the environment, all the Spack environments that we have available. Now, all those environments that are captured become handy when we get to using Spack at the deploy stage, because that's what we are going to activate. Those environments that has been captured, those are what we are going to activate and have installed. Okay, so it grabs all that. If there has been an update to an existing environment as well, we have an algorithm that would look at the commit hashes, dictate between previous commit and current commits what has changed. So over here, for instance, we are dictating new Spack environment. So within the Spack role, so this is the Spack role, we have the environments, the names of the environments, and then the Spack versions that are used in building those environments. So it would go in, our algorithm will go in, grab all these environments that exist, and save it in a file for us. That way, when we get to the point where we want to activate the environment, we know what environments we are activating. Okay, so say there has been an update to Spack. The updates can only be, because there are 2 things that are triggering the pipeline. It's either a merge request or a pull request, or a merge request or a push to the main branch. So if it's on the main branch, then it's going to look at the previous commit and the current commit, see what files have changed. It's specifically going to look for, so the file structure or the file hierarchy we have, the feed file name is the environment. Okay, it's the Spack environment. So it's going to grab that, save it in a changed environment file, and so we'll have all environments that have changed in that environment file. Now, if it were on a pull through a merge request, the pipeline was triggered through a merge request, then what it's going to do is it's going to look at that merge request branch and the main branch, and then it would also dictate what has changed from those environments. Now, it installs Ansible and then runs the playbook as part of the build stage. And so when it runs the playbook, that's when it's going to configure Spack. It's going to install lmod and configure lmod. If there are other rules, say for compilers, say something like GCC, it's also going to install GCC for us and build a module as well. So at the end of the build stage, the layout is going to look like this, depending on what roles we have. So the roles will specifically map onto, so there's the system name and then the different roles. Some of these are not roles. Module files are going to be dumped in here. But the Spack configs is also going to be here once it's done with running through the Spack role of the Ansible playbook. Okay, then we get to the point where it's now Spack taking over, right? Because at the deploy stage, all we are doing is using Spack for the installs. So if it's an environment that is new, it's an entirely new environment, then it's going to start everything from scratch. Now, if it is an update, okay, then that's going to be in our changed environment file. It's just going to go in, let's say, for example, an HDF5 in a new version of HDF5 in CPU 2509 GPU or CPU. It's just going to go in and specifically install that version of HDF5 for us. So with our repo, the Spack.log file and all these are up there already. And so when it pulls it, when it runs the playbook and it gets to the Spack part in the deployment stage, all it's actually going to do is to install. Okay. And so over here, it goes through a loop. So change the environment, every environment that has changed that it has captured through our detection algorithm is going to be in the changed environment file. It's going to loop through it, activate that environment, and do the install. Here, we use the -j for it, but just in this, I didn't put it over here. Okay, so then, so that's if we had a changed environment. Now for a new environment, it's the same thing. So whatever new environment it has captured, that differ from the very first deployment that it had in the Spack environment file, it's going to loop through that and have Spack install those as well for us. And so at the end of the day, all the different environments that exist, say they are new environments or updates to the new, or updates to environments, it's going to install those and have those build modules as well. Okay, so this is the setup we have right now. We are looking at ways by which, because Ansible is idempotent, so if there hasn't been any changes, when you run the playbook, nothing should change. We should expect that it will be in the previous state it was. So Ansible should be able to track what files or whether there has been any new Spack environment that have been added, or whether there has been any updates to Spack environment. So we are looking at being able to track that down from Ansible, and then relay those directly from Ansible to Spack so that we can have those environments activated and installed. And we are looking towards Spack CI to help us with that. One of the Jacama CI developers that has helped us with this is actually pushing, it has some ideas on Spack CI, and so we are looking at that to improve upon this. But for the time being, this is what we've set up for our moderate enclave systems. And so here we have been able to walk through some CI/CD way of automating software builds at the OLCF, not only on OLCF systems, but on Air Force systems and on newer systems as well. At least that, at this stage, it's kind of streamlined the process for us. Unlike when it was just one person working on Spack files, and you would have to wait, or if the version that we are using, if users request packages that are not in that version, we'll either have to go and install it by hand, or go get a new Spack version, install it somewhere, and put the modules, direct the modules to a specific location. This has streamlined the process a lot better for us, and so that we wanted to share that, and that's it for me. If there are any questions.
Okay. Thank you, Elijah. I think we have time for a question or so. Ryan, do you want to come up?
Yeah, I'll be in the hallway in case anybody.
I have one question.
Oh, okay, sure.
So as you add to existing environments, so new Spack packages, how do you control so that the packages that are already installed on the system don't change underneath the user? So it's only additive and not destructive or changing.
Yes, so because this is already built in a staging area, okay, the Spack, the log file that we have, there's nothing changing. The only thing that is being added now is a new, let's say a new package. So the original thing stands, it's not concretizing it, so nothing is changing, it remains the same. The only thing is the new package that is being added onto it. Yeah, so the Spack.log file remains the same, it's not changing, so that's how we are ensuring that things are the same. Because if you reconcretize, then the hashes will change, right? And then that's when you would suppose that at this point, a package will be different from the previous version. But we are not concretizing through the CI, everything remains the same. Mm-hmm.
What do you do when you do have to reconcretize? Like if you have to force concretize something in your environment, do you iterate on that outside or something, or how do you deal with that?
Yeah, so that's something that we would do. So in your staging area, when you are working on adding a new package, that's when you would do the force concretize and all that. But at this point, for the CI, we would not have any of those happening. Yeah. Mm-hmm.
Okay, thanks, Elijah.